When you learn to scuba dive, you learn that the underwater environment is quite different than the surface world. And you also learned that water is heavier than air. Pressure is a force applied to a surface. The deeper you descend, the higher the pressure is. An object filled with air will contract as you descend and expand as you ascend. And last but not least, when you breathe underwater while scuba diving, you breathe air at absolute pressure. In the physiology portion of your open water course, you learn that the air we breathe is mainly composed of oxygen and nitrogen. And when recreational scuba diving, we should pay special attention to the effects of nitrogen on our body, because nitrogen can cause nitrogen narcosis and decompression sickness. You also learn that scientists have been researching the mechanism by which our body absorbs and releases nitrogen with changing ambient pressure for almost 300 years. And several theories have been developed in that time. Despite this, as of today, decompression theory is not an exact science, as there are still many factors not completely understood. And decompression theory is a best guess in modeling the absorption and release of inert gases in our body. The first of such theories to be widely used in the diving industry was the one developed by John Scott Haldane and condensed in his well-known dive tables. With the increased popularity of recreational scuba diving, several certification agencies introduced their own version of dive tables. One of the common aspects of dive tables is that they are designed for a dive with a square profile. Basically, they assume that the diver spends all of his dive time at the same depth. Another common limitation of dive tables is that they are using depth and times in ranges instead of real values. Also, they tend to have very small numbers and letters that are difficult to read. The relentless advances in semiconductor technology and manufacturing processes, combined with the improved decompression algorithms, have allowed engineers to design reliable and affordable dive computers. Thanks to their integrated pressure and temperature sensors, dive computers give you a real-time depth and water temperature indication, and equally important, their decompression model estimates in real time the amount of nitrogen in your body. Last but not least, they allow you to closely monitor your ascent rate. In summary, compared to dive tables, dive computers track your dive profile more accurately, offer more features, and build a more detailed estimate of the amount of nitrogen in your body. To learn more about diving with dive computers, take the Introduction to Dive Computers online class. Press next to the bottom of the screen.